Hey there, scientific brilliant people. How are you today? So today we are going to learn about the lightning, the formation of lightning in the upper atmosphere, what are lightning conductors, the history of Benjamin Franklin, and how did he come to know about the lightning conductors and so. So lightning basically involves three-step process in understanding how a lightning is formed in the upper atmosphere. So the first process is evaporation and cloud formation. And I'm sure everybody understands this process well. Then the clouds, they get charged, and finally the discharging takes place, and finally we see the electric current flowing in the upper atmosphere in form of the lightning. So here let us now begin with the concept of lightning. Suppose this is a ground, and on one hot day the air which is just above the ground, so I'm talking about this air, that is also hot. And why it is so? Because the air which is just above the ground is also very hot. Now this hot air actually consists of the water vapor. So let me draw some water vapor inside it, because air is a mixture of gases and water vapor is a very crucial part of this. Now as the hot air rises up, because hot air is light in nature, its density is less, so it will rise up, and as the hot air rises up, it is actually moving away from the hot ground, so it starts condensing. So inside the hot air, now the hot air starts cooling down, and finally these water vapor, they start condensing to form small water droplets. So very small water droplets are formed. Still the cloud, so this is actually the formation of cloud. So due to evaporation, the water vapor goes up in the sky. Lots of water changes into water vapor and finally going up in the sky to form clouds due to condensation. Still the cloud keeps on moving up, and finally a time comes when the temperature of the cloud drops even less than 0 degrees Celsius, like this. And then we see that the water droplets which are present inside, they convert into small, very small, tiny pieces of ice. Very tiny particles of the ice. Now these ice particles, they keep on colliding with one another. Now during collision process, some of the ice particles, they lose electron. So suppose this is an ice particle that loses electron. So when this ice particle loses electron, it will become positive. Lack of electron becomes positive. As well as some of the mass is also lost, so it becomes lighter. On the other hand, this electron is being received by another ice particle, which becomes negative, because after the acceptance of the electron, all objects become negative, and some gain in the mass takes place. So this becomes quite high in mass, quite bigger in mass compared to these particles. So they actually become massive, slightly massive than this one, or heavier. Now, so what do you have inside the cloud? Suppose this is our cloud. Now inside the cloud, let me use another pen. Inside this cloud, the ice particles collided. Due to collision, some of them lost electrons, some of them gained electron. Those who gained electron become negative and become slightly heavier, and heavier particles, they always settle down. So that's why the bottom part of the cloud is negative, due to the presence of ice particles which have already absorbed electrons, and the lighter particles which are positive, they move up. So the upper part of the cloud is positive. So this is the second step and first step together that I have explained you people, because in the second step, the first step is evaporation and formation of clouds. The second one is the charging of clouds. So till here our concept should be very well clear that what happens. Now the third process is called the discharging of the cloud, that we are supposed to understand. So the last step, that is the discharging of the cloud, has to be understood with the help of an example. So here we have a neutral sphere which is made up of metal mounted on an insulating stand surrounded by air. Now air is an insulator, we know that, and air is a mixture of gases, and all gases are made up of atoms. So I am going to consider the single atom of air to be like this. So this is an atom of air containing a positive nucleus and an electron revolving around the nucleus. Very simple model of an atom, just the positive nucleus and a single electron revolving around the nucleus. Now I am going to pour negative charges on the metal sphere, or say that I am constantly adding negative charges on the metal sphere. Now this metal sphere is going to attract the positive charge towards itself by the force of attraction, and it is going to repel the negative electron away from it. So you would see that as I keep on adding more and more electrons, the sphere becomes more and more negative, and as the sphere becomes more and more negative, the attractive force on the positive nucleus increases. So you may see the shape of the atom something like this. The positive nucleus being strongly attracted and the negative electron strongly repelled, and the atom is on the verge of ripping off or breaking. When this sphere is added with still more negative charge, the force of attraction by this sphere on the nucleus becomes so prominent that it is going to break the atom, and it is going to absorb the positive nucleus, and it is going to kick off the negative electron apart from it. And when this positive nucleus goes inside, it combines with one electron and neutralizes some part of the sphere. So when this situation arises, we say that air loses its insulating property and becomes conductor. Why? Because now that there are charged particles in the air, and all those charged particles like electrons, they are in motion, which constitutes current. And when this happens, when the atom gets ripped off into two parts, and when the electrons they start moving, you see current and you see lightning and you see this thing. So lightning is basically when an atom of the air breaks off into two parts, and that is only possible when the sphere gathers too much of negative charge such that it is going to rip off the atom into two parts. When this happens, the air loses its insulating property and we see lightning in the atmosphere or in the air also. So now let's apply the third step, that is the discharge process from the clouds. And for that we have a cloud, and we have already discussed that the bottom part of the cloud is negative and the upper part of the cloud is positive. So this is a cloud which is charged, heavily charged, and this cloud wants to get rid of these charges which it has gathered. So the cloud basically wants to remove its charges. That is called discharging process. Now this is Earth's surface, and we consider Earth to be conducting. So these are sand, gravel, which are all conducting in nature. So just assume if a negative charge is placed beside a neutral atom. So suppose if a negative charge is placed beside an atom. So atom is basically a positive charge and a negative electron. So this negative charge is going to attract the positive towards itself and going to repel the negative electrons away from it. So you will see the atom something like this. In the same way, you will see that these are all the atoms, and from the atoms the electrons will be pushed down away from these negative charges. So you will see that the top part of the Earth becomes positive, and the negative part of the Earth becomes, the bottom part of the Earth becomes negative, and the electrons are being pushed down like this. So the electrons, they go down. Correct. Now in discharging process, what happens is these negative electrons, they want to go towards the Earth because the Earth is positive, and all negative electrons will now go inside the earth, which is called a discharging process. So what is going to happen is, here is an atom of air. Now this single atom of air consists of positive nucleus and a single electron. So that is to be considered like this one, right? And if this cloud is very heavily charged, then it is going to rip off the atom into two parts, and it is going to attract the positive ion towards itself, and the negative electron would go inside the ground, because this negative would be attracted by this positive earth. In doing that, if this positive ion combines with one of the electrons of the this cloud, then the bottom part of the cloud will become neutral. So as you can see that some part of the cloud is now discharged, because one atom of the air got splitted up and one positive ion went up, and now this positive ion has neutralized some of the sections of the cloud, and this electron has moved down. In the same way, what is going to happen is, there are many electrons and there are basically many atoms which are going to get split up like this. So this is another atom, this is another atom. So there are crores of atoms which are going to get splitted up, all positive ions moving up, all negative electrons coming down like this, and these positive ions are going to neutralize different sections of the cloud, which is called a discharging process. So indirectly this electron is neutralized and one electron proceeds towards the ground. So this is how slowly and steadily you will see that the charge on the bottom part of the cloud gets reduced, right? And thereby you see only the negative electrons moving down like this, and the stream of negative electrons going down is what we call as lightning. So you will see that the lightning is going to take place from the cloud to the ground. This is how it takes place, right? So the last slide in which I want to draw your attention towards is the direction of lightning. Here you have three similar clouds, and then on the ground we have a person who is barefootly walking. Then there is a tree, then there is an insulating rock. Consider this piece of stone to be an insulator, or big piece of wood can be also considered in the place of this one. And then there is a taxi. Now here a person is inside a taxi. Now my question is, who is safest over here, right? Should you go out of the car? Suppose you are traveling the car, so should you go out of the car or not? That is a question. And you will also understand the direction of lightning. See, in all this situation, the clouds which are heavily charged, they just want to get rid of these negative charges. So what is going to happen is, over here, even though this is an insulator, this air will be ripped off, positive streamer would be going up and negative electron would be going down. So there will be a strike on the stone, and since lightning strikes are they carry too much amount of heat, so it may melt or damage this piece of insulator as well. So no matter you have an insulator or conductor, the lightning is going to strike. Here we can consider our body and the tree as an conductor, because inside our body we have water, minerals, so our body is conductor. These negative clouds will pull out the positive ions from our body in the upward direction, and the negative electrons would be pushed inside the ground. So now these negative electrons want to come towards positive ions, so there will be a lightning strike on us also possible. And in the same way, all the positive ions which are in the conducting body, like this tree also contains minerals and water in xylem cells, so all the positive ions will be pulled up by these negative charges by the induction phenomenon, and negative electrons will be pushed down to the earth, and there will be a lightning strike on the tree as well. Here also, people, there will be a lightning strike, but there is something called a Faraday's cage. This topic will come in grade 12, that if you are inside a car, you should never leave the car. The lightning strikes, due to that the car's body will be perfectly charged, but inside the car there will be no charge, because the metal, it is a property of metal that all charges they reside on the surface of the metal body, not inside. So in that terms you are safe. But you will have to be very careful when you get out of the car. From inside you can open up the car, but again if you try to close the door, you will get a massive shock, because then your body will be grounded and these all charges will pass through your body inside the ground. So better, if you even want to close the door of the car, use a stick, but better don't do that. But you are safest inside the car. Outside you will always have a possibility of lightning strike. Now another thing, these negative charges may also go towards these positive ions on the other cloud, so the lightning can be possible in this direction also. So hopefully people, you have understood the explanation, and I'm thankful that you have watched this video, and do like, share and subscribe my channel, and if you have any doubts, please do comment in the comment section. Thank you for watching the video.